Okay, so hi, this is week 3, and we are going to next topic is text classification and naive Bayes, and so we want to understand this topic. Let me go through slides. So this is the very simplest case of text classification, where we so for example the classic problem, it can be called, to find out if this message is spam or not, because so nowadays we have less problems with this one, but actually more, spam is some message that we doesn't want to see. Mostly it is advertised messages, like people take mails from any open sources. Like in previous example, as you saw, there was some pages from Stanford stuff, and some of them had mails, and people can write some scrappers and find out all these mails and send them from their servers, and you can do some advertisement with this method. Of course, you as a receiver of these messages do not want to see them, and you want to you do not want to see all of these messages, and you want to prevent these things. So this is a classic problem of text classification, when you have message and you want to classify it, and you want to filter it and to see how it's going on. Oh, sometimes even other methods, like who wrote which federal papers. So there was anonymous essays tried to convince New York to ratify US consumption. So there was some essays which was very important in United States history, and they were anonymous. Why? Because nobody. So there were 3-4 people who, like group of people who could write it, and but we so there was problem understanding who wrote it, and to solve this problem, Mostelia and Wallace used Bayesian methods to find out it, and so this is also a classification method. Who was after of these messages? Male or female author, so you can see these texts and try to understand if this was written by male or female. You can take a look. So you see that there are some writing styles of male and female authors. So you can see that there is a paper about this one, informal written text. So as you see that in second one is most probably written by female, because it is written with usage of many like adjectives and adverbs. So this can be some insight, or you can understand it by the topic which was written. So second one is about emotions, and first one about some war and etc. So we can assume that males write about some war and actions, whilst women write about emotions. But of course, as you can understand, that sometimes not all male write. Maybe some male may write with these things, and some females writing these things in this form. Also, it can be there's like ethics problem in machine learning. There are in artificial intelligence. So when we have some data and we can reason with this data, so we can say, for example, male or female based on their writing, but we cannot assign him as male or male. So it's also a different problem in artificial intelligence and machine learning, probably. positive or negative movie review. So also, for example, you want to understand is your movie was loved or not loved, because or for example, whose actor is who, what did they like or didn't they like, because movies are very they are very expensive, and they are not understandable what is the result. Do people like it? Do not people like it? So many now movie industries in Hollywood tries to use data, and they by using data they can, for example, create new movie, and when they are creating movie they kind of trying to predict will it be like it or not. So this can be also maybe for some of you it may be not intuitive, because we think these things like they are creative, but actually by using data these things may lose its creativity charm, and become some like engineering work. You try to uh, sublime many things together and to make good thing. So for example, this one, unbelievably disappointing. This is like unlike, dislike, full of zany characters of rich applied satire and some great plot twists. So also this is positive. This is the great screwball comedy film. It was pathetic, and etc. So you want to understand what is the movie and how it is. What is the subject of this article also can be, for example, you have a big amount of data and you want to categorize it. You want to understand what are these. So for example, for our university, there may be like many mails, and as I understand, for example, deans and student office, they got many mails and they have to answer them. So for example, you can filter them to work with it. So for example, by using this type of category hierarchy, you can help to reduce their work. Text classification, so all of these problems are subject categories, topic, genres. So for example, what is news category, how to do it, spam detection, authorship identification, age, gender identification, language identification, sentiment analysis. Yeah, so all of these are problems of text classification. Text classification, so we want to formalize the problem. So input is a document, we can denote it as D, a fixed set of classes C. So this can be spam or not spam, male or female, sport, politics, or something like this, negative or positive. Classification methods, hand-coded rules based on combinations of words or other features, spam, blacklists, or so we can specify some features. We can like say, okay, so there are some mails that start with these things. They are definitely spam. So for example, we can assume that if this person didn't send you a mail before, if you didn't send this mail some message, so it can be spam. So this is hand-coded rules. All things that are used, that are solved with machine learning, they are firstly tried to solve by hand. So for example, you have some little problem and you want to solve it by hand. So for example, like in last assignment for detecting gender of persons, most of you, all of you did write some regular expressions like Yevna, Ovna, which, and Olo, Kızı. So these things are you write by hand. So these are called hand-coded rules, or rules-based. So you write rules, and by these rules you specify. So actually, all of artificial intelligence methods, machine learning methods, before them there was rule-based. So maybe if you try to solve this kind of problems, first of all you must try using rules. So you first of all must see the data set and try to solve it by rules, and maybe by these things you will get some insights. And so for example, dollars and have been selected. So for example, there might be some messages, if you look into spam, you'll see some like general patterns. Accuracy can be high if rules can be refined by expert, but building and maintaining these rules is expensive. So what is the problem is that you should find out all of these rules, but these rules are very expensive. Why it is expensive? Because it requires you to find these people who will write them, and you also, if there will be very big data set, you will be required to have some person who will look after that person, and you will also need some environments where they will be like setting this. So for example, in okay, do we have this one? Maybe. So, for example, in Yandex, we have Yandex Taloka, where are so some not rules. Oh, okay, these rules. Sorry. So sometimes hand code rules you need some specialized person. So you, for example, you want to solve problem with text classification and defect detecting genre, so you will need to find the expert who is expert in detecting genres. So he is because he is expert, he is very expensive, so you his work will be expensive and you will give a lot of more money. Supervised machine learning, so this was first one, hand coded rules. As I understand, you write some rules and these rules help to solve it. So to write rules, it's you should be expert to define some rules. Supervised machine learning, input a document D, a fixed set of classes, a training set of M hand-labeled documents, a learning classifier. So in this case, you use machine learning. Machine learning means that you will have some training set. You will have hand-labeled. So for example, you have million of documents, and you classify 10,000 of them. You find money and give it to experts who classify them by 10,000 documents, and others you classify by machine learning algorithms, which we will learn later. Supervised machine learning, any kinds of classifier, naive Bayes, logistic regression, support vector machine. So there are many. The maybe easiest of them, k nearest neighbors. So you can learn it. Naive. So, but we will learn naive Bayes today. Naive Bayes is also, it is simple and intuitive. You can understand it intuitively. It's not like support vector machines, which are somehow very mathematical. In contrary with this one, it's like if you know probability. Relies on very simple representation of documents. Document bag of words. What is bag of words? Bag of words is that you, for example, have this text, and then so there's some words. Some of these words are considered as, for example, you take all of these words and say, okay, this text contains love. Love is mostly probably positive, sweet, satirical, great, fun, romantic, laughing, recommend, etc. So they can be considered as positive, and you say you removed all of this one. Like not remove, but you neglect them. Their weights are very less, so you say that it has two words great. You have two words love. It has one word recommend and one word love, etc. So this is like bag of words document classification. Okay, so we go again to these rules. Okay. Again, so let me write. Okay, let's write it here. So let me remove this one, Tadash, and this one, Tadash. So we have this document D and class C. So this is Bayes rule from probability course. So it's something like that. If P C is a class C given D, for example, it's like if they accurate, what is the probability of occurrence of C? And in this case, you say that what is the probability of class C, for example, spam, if we have document D? So actually, we do not now know answer for this answer for in general case because we do not have all documents, all type of documents. So you have something new, and you cannot find this probability. But you can apply Bayes rule, which is less. So for example, this one is probability of class, which is, for example, you have 4 spam and 2 not spam. So for example, probability of this one, if P spam, it will be like 4 divided by 6. So this is actually it's easy to find. And this one, probability D, and this one, they are actually sometime if you look it straightforward, they are harder, but we will understand it later. So okay, CMAP, and also you can do something like this. You can actually remove this part document. Okay, yeah, so you can actually remove this part because actually you will compare many these ones. So one of them will be probability of C given D. So for example, if you are doing a text, so for example, you write P some spam given D, and in other place you want P not spam given D. So actually what you want to find out which of them is bigger, because whose probability is bigger, that means that, for example, is P spam is 0.6 and P not spam is 0.4, that means that P spam is bigger. So actually you want to compare two these things. So when you compare two these things, they are denominators, their part, they are equal, they are the probability of document equal. So actually you don't need to find this part. So this is explained here. And the next thing is that we want to find that. So for example, we said that actually we need to find this one, P document given C. P document given C is equal to multiplied by PC. We can say that document is not, is some sequence of words. So Begefordt says that there is no difference, there is no importance of their order. So you can assume that only Begefordt, you say that word x1 how many times occurs in C, how many times occurs x2 in C, etc. So let's go back. Okay. Assume position doesn't matter, as I explained before. So this is, instead of D, instead of this formula, P D given C, you use this one. What does it mean? So you simplify this method because we do not have probability of document given spam, but you have this one, x1, x2, and this is the words inside of P document. And Begefordt's assumption, it says assume position doesn't matter. What does it mean? It means that actually we do not need their like positions. Like in real life, it matters, but we try to simplify. We say that okay, if there is words, how they are ordered, we do not look. Assume the feature probabilities are independent given the class C. So they are like, we say that these factors are independent. So we say that Px1 given C, Px2, they are equal to this one. So we make two assumptions which are important here, and that makes our problem solvable. So this one is Px1. So how does it like? To solve the problem, learning the multinomial naive Bayes model. So actually in machine learning, sometimes learning can be thought as some process of training and etc. But in naive Bayes model, we do not have training in that thought. So learning is just only going through data and counting it and then apply some formulas. So this can be considered as learning. For example, neural networks you have to train to learn, but in this case you have to only look at the data and find this data. So this significant difference. We have dog count. So to find out this probability of word I in spam, for example, you count how many times word I occurs in spam. And then you count how many times word occurs in all documents, in all type of documents. So this is the very easy formula, which we go back. And so we find out this one. So for example, fantastic in positive, you count fantastic in positive, and then count. Okay, so this is count. Okay, so I think I made an error. So you do not count word. In this case, you do not count word in all documents, but you count words, all words in positive, in the spam documents. So you count all words, and then it is divided. So for example, you count word, all type of words in positive. So actually you count all words in positive documents. And also Laplace add one smoothing for naive Bayes. From last lecture you may seen that it was something like this, +1. You make it, for example, if you have zeros, it will make some error. So it will be 0 and all of them will affect. And here you have to not make 0, you add 1 to all of this, and then you plus v, which will help to be normal looking. So you must add v. So this is the pseudocode how to learn. So for each word C, J in C, you calculate actually how many times each word occurs in all this. So let me continue after some time.